All right, so this week has been a busy week. Not any new PRs that I saw, but a whole lot of closed PRs and updated PRs for that matter. So everybody's trying to get stuff in for Quincy. Let's go through the list. First PR, Rgw Zipper. This is a bug fix PR. We noticed that Rgw and master was very, very slow in some age binning tests I was running for the age binning PR that also just merged. And it turns out that that was due to an older PR that was mostly cosmetic, but did have a change that ended up loading stats for every bucket load in Rgw. And it turns out that was a fairly easy fix, so we got it in quick, which is good because we won't have that issue going into Quincy now. But the fix basically returned us to previous performance levels, so that was really good. The TTL cache implementation PR merged. I didn't see a whole lot of further discussion on it. I think it just needed to get through some testing. Josh Salmon's primary balancer PR merged. Laura, I think you merged that. Anything new to report on that one?
Nothing new. I guess the main thing is we decided the original PR had a documentation commit on it too, where Josh had written a new document in the developer guide that explains the primary balancer feature. But since that part of it hasn't been implemented yet, we moved that over to a different PR that will be merged after Quincy branches off. But the refactoring code was merged. That
Cool.
just refactors and simplifies the calc PG upmaps code.
Okay. Excellent. Next, Adam, your fine grain locking PR finally merged. That's exciting.
Finally, it took half a year.
Yeah, the complicated ones do, right? Anything new on that one? I think we saw some performance advantage with it, but I have trouble remembering.
Yes, there were performance advantages, but none of the tests we are running as a quick performance check is showing that. So I'm waiting to see them in more elaborate Quincy testing.
Okay, cool. Let's see next. The cache age binning, also a multi-year PR that merged finally. So like Adam's tests for the fine grain locking, we don't actually see a huge performance gain with this, which was very disappointing. But in fact, the Rados bench perf test that we run through Jenkins actually did show a little improvement with it, which was nice. So the bigger benefits we get from this are more fine-grained control over the caches in BlueStore, and also much better information regarding the relative ages of the items in our different caches that we present through the performance counters. So overall, I think still a good win. But just not the big win that I was hoping for. Let's see, next. Igor's PR on handling O-node binning shards trimming, and also Adam's PR about refactoring O-node reference counter and pinning. Both of those were closed by the stale bot. So these were two different paths we could have gone down. I know there's been some other pinning code changes recently.
Exactly. They are outdated, and it's fine because we have a new one on the queue. It's on new updated category. So they are clearly closed, and they will remain closed forever now.
Excellent. All right. So we got a path for that, which is very good. Then the other one that closed by the stale bot, auto-tuning of the MBS cache memory based on RSS usage. That one, I have not seen updates to that in a very, very long time. I think personally, my feeling on this is that we should be using the priority cache for this anyway, since the problem that you hit when you use RSS memory is basically try to use RSS memory to judge how much memory to use for caches. That is using RSS can result in very, very nasty swings that you really don't want to deal with. And the priority cache kind of gets around that. So that would be the route that I'd advocate we go with this. But in any event, that PR was closed due to inactivity. So we'll see what the CephFS team decides to do with it going forward. Okay, next, updated PRs. Use thread local pointer variables to save the shard pointer. That was approved by Ronan. So Ronan, are you here? I don't see Ronan today. All right, I didn't look closely at that. So I guess Ronan was happy with it though. Next, make shared blob FSCK much less RAM greedy. Igor's not here. Adam, you looked at it. I looked at it a little bit. I think, assuming that it's tests out fine, we should just get it merged as quickly as we can.
Correct. It's fixed the problems that were here before. Fixed. There are still improvements, I think, to be made, but mostly on selection of hash and using two separate bucket lists for hashing. It's just thing of performance and granularity of check and verification, which I just wavered because it will work as it is. It's just an improvement thing. So thinking that this is as important, just accepted that and leave the discussion for future.
Yeah. Adam, if I remember correctly, we're not doing the... I know we're trying to use a percentage of the OSD memory target in that now. Will it actually bound the memory usage now?
It does bound memory usage.
It does? Oh, fantastic.
It does. Basically, OSD memory target takes care of our caches, and for the data structure, bitmap data structure for shared blobs, it's fixed allocation of fixed size. So it stays really within memory target. I'm pretty satisfied with that. Of course, we might pay for that with an extensive unneeded blob rebuilding, but that's what we have to do. There is no other way around.
And if we give FCK more memory, avoid that and have it be faster?
Not really, because only it works like this. In worst case, if you hit in some bucket that there is an error, you need to rebuild all shared blobs that were somehow involved with that bucket. So if there is no errors, there is no need to give more memory. Even I would say the less memory, the faster it will work. But if you would have a very broken state with a lot of shared blobs requiring repair, then having more memory would help.
Yeah.
That's it.
Yeah. That was one of the reasons I was advocating for using the priority cache for this, because we could then basically inform FSCK up to how much memory it should try to target to use. But it's a minor point. Let's get this merged and then we can haggle over that kind of thing later.
I don't think we will ever because it will work. So there would be no need for us to ever get back to this topic, at least in shared blob department. There are other things that may eat memory during FSCK, and that might be a problem. But shared blobs are done now.
Okay. Sounds good. Well then, let's see, moving on. The skip onode with cap iteration for empty directories, or inode, sorry, this is MDS. I got myself way off this and no movement. Where am I? Okay. I think next, do we talk about? Oh, this is the pinning logic. This is the other pinning logic PR from you, Adam.
Yes, that's actually both our work, but in my PR this time. That's why the other solutions were closed and will stay closed.
Okay, sounds good.
That's a simplification after we merged Igor fix to O-node pinning. So now we could make some more simplification.
Nice. Yeah, I am very happy with what you guys came up with compared to what we were doing earlier, especially the one I tried to do. So this is excellent. Okay, next, Radek introduce huge page-based read buffers. Is Radek here? No, I don't think so. Igor reviewed that, and I think he approved it, so that looks good. Next, optimized PG removal by Igor that previously was failing tests. It's had more reviews and discussion and updates. I don't know if anyone's actually approved that or if it's seen any new testing, though.
No, it still requires detailed review, and I don't think it will be in time. No, it will not be done until tomorrow.
Yeah, I understand. It did have an approval by someone, I think, early on, but we probably need someone in addition to approve it. Adam, are you planning to look at that?
Yes, but not until Monday.
Yeah, exactly. Yeah. Okay. No worries. Cool. Else, last one. Test object store test. This is my OMAP edge thing. Neha just marked this as not stale because we do still want it in some form. Probably not in the form that it's in, though. Basically, with store test, these tests take a while, and we probably don't want it to make store tests take that long. Also, we can't easily change the parameters of the tests that way with the G-test suite. So maybe this becomes its own separate benchmark or something. And maybe we don't tie it directly to the object store, but we try to go through an actual OSD. But anyway, those are big changes, lots of work, not going to happen for Quincy. So I think that's all I had in the updated categories. Did I miss anything from anybody?
Not that I can think of.
Okay, sounds good. Then moving on. So the only real discussion topic I wanted to bring up this week, we've talked previously a little bit about Quincy performance tests. Neha brought it up, I think, last week. So I think for NVMe tests, I can probably take this on. We've got quite a few templates for different tests that we want to run. So my thought is let's use Mako for this. We can actually do a fairly decent sized cluster on that hardware for testing. So we've already got kind of some fairly straightforward FIO tests that we can run against RBD, CephFS, possibly also look at TCMU runner and NBD. So basically iSCSI and NBD. We'll see if that still works. We did have it working at one point through CBT though. So theoretically it may still. And then HSBench for RGW, COSBench is kind of bit rotting and has been for some time. So That's by far the easier route to go. We don't have any real tooling yet for IO500 MDS performance. We do have. I have some stuff to make that sort of automated, but not real straightforward. And the results we get from it are usually really chaotic for a variety of different reasons. But we'd have to run a lot of IO500 tests probably to see what kind of trends we'd see between Pacific and Quincy. So I'm thinking probably we should just leave that out. It's also very time intensive. OMAP bench, it might not be a bad idea to run it. It doesn't take too long, and there have been some fairly significant differences we've seen between releases in the past, so it might be worth looking at. And then Neha said that the DFG team can do their own hard drive tests, so I'm thinking let's let them do that. I also really like having multiple people running tests because sometimes it shows things that one group overlooks, the other group happens to catch. So what else? Neha, you brought this up. How does this sound?
This sounds perfect. I think it gives us good coverage across workloads and devices with you and
Cool.
the DSG.
Cool. The good news is that I've been doing a lot of testing as part of the age binning PR, and I'm not seeing anything right now in the RGW or the RBD side that shows any kind of major regression versus Pacific based on previous numbers I've gotten. So I don't think we're going to see any real surprises for kind of the common case workloads. It's possible we could still see some things in other areas, but at least based on what we've got in master as of the last couple of days, I don't think we should see anything real nasty.
That's good to know. I'm just curious, like the test that you plan to run, how many OSDs are you trying to spin up?
I think we should do what I've liked to do in the past when I have the resources to do it is both kind of like single OSD tests, because you kind of are able to much more aggressively push an individual OSD that way, and then also like a big cluster test. And on Mako, we can do if we target just a single OSD per NVMe drive, we can do OSDs. Otherwise, if we go with like 4, we could do 240.
Okay.
So we can. Yeah, I'm open either way. If you want to just try to go for like maximum number of OSDs, we could probably do 240. Memory gets a little tight, but we can do it. Otherwise, we can we could give the OSDs a very, very comfortable amount of memory at just using one OSD per drive.
Yeah, I think we can do the comfortable way. I mean, like in general, I would want to do something that we recommend to our users. So we generally have anything lower than 4 gig is definitely not something we want to test. So with 240 OSDs, how much memory would each of these OSDs have?
Oh, let's see. If I did 240, each node has 128 gigs of memory. That would be 24 OSDs each. So we could probably do 4 if we weren't co-locating like RGW or MDSs on the nodes. If we co-locate RGW and MDSs, then that gets tight.
Yeah, in any case, I think we can go on the safer side and get the OSDs good amount of memory.
Yeah, we could also very easily do two OSDs per NVMe drive, and then you'd be you could easily have 4 gigs for each one, and plenty of space for other daemons and clients at the same time, and then that'd be like 120 OSDs.
Yeah, that sounds good.
Okay.
So you're going to be using CBT. I was just wondering, maybe if we have time, we could do the recovery testing as well. I know there were some improvements that Sridhar made to the recovery tests, so maybe we can do that as well.
Yeah, certainly. We could. I'm not sure. I haven't looked closely at the changes that they made, but beyond reviewing
I think
the one
I think
PR.
Sridhar is here. He can probably talk about it.
Yeah, go ahead.
Only if his mic works or audio works.
Yeah.
He was having issues earlier.
Yeah, can you hear me now?
Yes.
Yes.
Yeah, there have been quite a few call drops from my end. Sorry about that. So yeah, so as far as the new recovery test in CBT goes, I think this essentially creates a couple of pools. One pool dedicated to the client, and the other pool dedicated for recovery-specific operations. So the way that the test works is to basically populate the client pool with a bunch of objects. In my testing, at least, I have basically populated it with about 100,000 objects, and then go ahead and create the recovery pool, and then what the test does is to essentially fail an OSD and wait for the backfill process to start, while all this time the client IOPS are going on. So that way we measure how the recovery proceeds against the client IOPS that are going on in parallel. And the test basically collects all the stats related to client IOPS and the recovery IOPS, and then that helps. And I also written a simple tool to graph the statistics related to IOPS, client-based IOPS, and how the recovery proceeds to complete in that time frame. So in a nutshell, that's what the test does.
And how does that differ than the recovery test that we had in there previously?
In this case, the pool that we create is much later. The recovery pool is created much later when compared to the client pool. So I think the test is basically the initial test that is already existing. That's the I call it the blocking recovery test, and the other one that I created now that essentially does helps in the creating background IOPS, background recovery IOPS.
Okay. Well, yeah, if you want to, we can. We'll just have to see how long it takes to get through all this other stuff, but we could definitely try to see if we could get that in for Quincy too, if you want to try in a much larger cluster.
Yeah. We could try that.
Cool.
Yeah, ideally, creating a separate recovery pool and all that may be fine, but maybe we can also just have a regular setup like an Rgw cluster and have the recovery test do some kind of bringing nodes down and capturing recovery stats, etc., in the existing cluster instead of having to create a separate pool for recovery and all that stuff, which was mostly for QoS performance purposes. So that's something to maybe keep in mind to adapt to this real world testing kind of stuff.
Yeah, that's how I think the original ones worked. We basically just you pre-filled in some data. You do maybe like an Rgw put workload, and then at some point, you have the recovery triggered where it marks down a bunch of OSDs and then kind of starts monitoring the behavior while that's the cluster is healing.
Okay, I don't really recall what you used to do, but in general, I think good time to revisit it.
Yeah. Assuming that the code hasn't changed dramatically since then, we should be able to do that pretty easily, I guess is what I was getting at.
Yeah. I think whatever Sridhar has added is extra stuff. You can, I think he's added a parser and all those recovery stats are now nicely collected separately, all that kind of stuff.
Oh, fantastic. That's great.
Yeah, if I'm not wrong, the earlier test used a single RBD image, whereas in this case, in the one that I have introduced, that essentially creates two separate images with two separate pools, and that's the basic difference, I think.
Okay. I don't think I've ever tried a recovery test with RGW. If I remember right, the hsbench wrapper supports it in the same way that the FIO wrapper does, but I don't think I've ever tried using it. Peter, have you looked at that at all?
I haven't looked at the Rgw case, Mark.
Okay. But we could try it.
But if someone is interested, I'm pasting the details about the new recovery test. I documented a few things. And just pasting it for, yeah.
That's excellent. Cool. So I think, Neha, I wanted to ask you, what do you think about like iSCSI, TCMU Runner, and NPD? We might be able to get them for free, essentially, other than the time it takes to run them. Previously, we've done that through CBT, and it's worked.
Yeah, I mean, if we have time for it, I'm all for it. I would say anything that comes for free, why not take it?
I guess the question would be, is it lower or higher priority for you than recovery?
I would, okay, I'm biased. I would say lower because I would really like to test recovery because of mClock changes and like making sure like recovery works fine. And like we have the high recovery profile with the mClock changes. I'll try that out as well. So that's my personal agenda. But yeah, as a global project, we can talk to Ilya and the RB folks to figure out how that, what's the priority on their mind.
You know, I suspect that iSCSI has not changed much at all since shoot, I'm blanking on his name. He left for Oracle a little while ago on the RBD team. But anyway, I don't think it's changed much in like the last year, just from talking to different people. So I mean, we can test it, but I don't think it's probably going to look a whole lot different than it did a year or two ago when we last looked at it. Ilya will probably know for sure, but that's just the impression I get. All right, well, I think we got a plan then for Quincy testing here. That was the only topic I had for this week. Anyone have anything else they want to talk about? All right. Well, if not, then I know everyone's really busy trying to get last minute PRs in here, so I guess we'll wrap this up. All right. Have a great week, everyone.
You too. Thanks.
Bye.
Bye.